Okay, business calculus students, this is the review of the skills that you need to brush up on before we are actually able to complete chapters 11 and 12, which is your chapter on limits and continuity and the derivative. So we're going to begin by reviewing some things from algebra that you may have forgotten. This is the quiz that you are taking. And the first problem says to write this exponential as a radical. Now, the review part of this, what you need to remember is that initially when you had algebra a long time ago, probably didn't even review this in 1630, there is a relationship between the radical form of an expression and the exponential form of the expression. So we're going to start out with the exponential form of an expression, not the one that we're looking at right now, because I want you to be able to convert anything that is an exponential form to a radical form. So we're going to start out with the expression 2x minus 1, close the parentheses, and we're going to raise that to the power 2/3. And what I want you to notice about this expression is that the power is a fraction. And when the power is a fraction, the denominator of that expression is going to give you what we call the index of the radical. In this case, since that denominator is 3, then we're going to be taking the cube root. The second thing I want you to pay attention to is that the numerator of that fractional exponent is going to be the same exponent as we're going to use underneath the radical. And then the constant, of course, is the base. And the base is the expression 2x minus 1. That's called the base of the radical. So what we see is that when we're going from exponential to radical form, then the denominator of the fractional exponent, which tells us it's a radical expression, becomes the index on the radical. And that the numerator becomes the new exponent. And it's now a whole number, but it's underneath the radical. And that box is the radical. So to proceed now with our first example, what we see is that we have the exponential expression, 11 to the 1/2 power. And that the denominator of that expression is going to tell us the index, and in this case that index is 2, of the radical expression. Our base, which is 11, is going to remain unchanged. It simply becomes what we call the radicand, which is the thing that's underneath the radical. And then the numerator of our expression, which is 1, will become the exponent underneath the radical expression. And of course, you know that we don't always write the index of 2 just because it's a square root. That's the one that we assume. If you don't see an index, then we assume it's 2 because that's the lowest index you can have. And we always assume that things have a power of 1 if we don't see a power. So actually, the way we're going to enter this into my math lab is going to be the square root of 11. So at this point, we'll move on to problem 2, and problem 2 says that we need to factor this expression. And the expression we're asked to factor is 3b squared plus 10b plus 8. And I realize it may have been quite a while since you factored anything. If you already know a good method that always works for you when you need to factor, then you don't necessarily want to watch my explanation here. But if factoring has always been the bane of your existence, and for most people it is, I think, I have a method of factoring that always works. The good thing about it is that it'll tell you if the thing factors, then you'll know it's factorization. And if it doesn't factor, you'll know that as well. And it involves 2 steps. Step 1, look for a GCF, greatest common factor. In other words, what we're looking for here is there a variable or a number that is common to all 3 of those terms? And in this particular case, there is not, because every term doesn't have a b, and 10 and 8 are both even, but 3 is odd. So they don't have a greatest common factor. So in that case, our answer to greatest common factor would be there isn't one for this trinomial. This is a trinomial, meaning it has 3 terms. But we always look for that. Then step 2 is, okay, I didn't have one. There's no GCF. So for step 2, what we're going to do is we're going to create a little grid that is, in actuality, it is a multiplication table. Because when I ask you to factor this expression, what I'm asking you is there a binomial with 2 terms times another binomial with 2 terms that resulted in this trinomial. And what we know from multiplying binomials together is that when we multiply the first 2 terms, then we come up with the first term of the trinomial. And when we multiply the last 2 terms of both binomials, we come up with the last term of the trinomial. What we don't know in this case, because it's already been combined into 10b, is what goes in these 2 boxes that added together to give us positive 10b. So the product of these two boxes, I'm sorry, the sum of these two boxes has got to be a positive number, and the coefficient of the b in both of those boxes has to add up to 10. And what you may not realize is that whatever those two pieces are, they are a result of the product of 3b squared and positive 8. So I'm going to multiply 3b squared times positive 8 and get 24b squared. And now I need to know other factors besides 3b squared and positive 8 that will give me 24b squared. But the catch is that I need to find the ones that those two factors add up to 10b. And obviously 3b squared plus 8 does not add up to 10b. So what I want to do is first recognize that in order to get b squared, my two factors must have both had a b in them, because b times b would give me b squared. So I know that's going to go in both of these pieces for the two terms that combine. I also need factors of 24. And even though it seems tedious, we're going to start out with the first obvious choice, which is seldom the right one, but we're still going to start out with it because it's easy. 1 times 24. And then the thing that I'm also going to consider is, since this is positive, I need, when these things add up, there needs to be a positive result. So kind of tuck that away in the back of your mind for a minute. Now another set of factors that give me 24b squared would be 2b times 12b. Another set of factors would be 3b times 8b, which of course I sort of have there. And then the next set would be 4b times 6b. 5b isn't going to multiply times anything to give me 24b squared. 6b would, but I've already listed 6b. So at this point, I know that I'm finished with my list of factors, because the next factor I would use would be 6b. It would just be on the other side. Now I'm going to look at the fact that both of these have to be positive, that this has to be positive for the result. And since the result has to be positive, that means the bigger of these two factors, since I'm adding, has to be the positive number. And this then will have to be negative. Okay? Now here's the problem. This is a positive quantity, but the change of signs here says that if this is negative and I'm adding these together, well, that's not going to give me what I'm after. Because negative 1 and 24 is going to be positive 23, but negative 1 times 24 isn't going to give me positive 24. And negative 2 plus 12 is going to give me positive 10. And of course, these all have b's. But negative times positive isn't going to give me a positive result. So the fact that this is a positive sum says either both of those have to be positive or they both have to be negative. And I know they can't both be negative, because then my result here would have to be negative. So that tells me that the only possibility that this is going to work at all would be if both of these sets of factors are positive. Not one positive, one negative. But then here I know that 1 plus 24 is 25b, and that doesn't help. 2 plus 12 is 14b, and that doesn't help. 3 plus 8 is 11b, and that's not what I'm looking for. But 4 plus 6 is in fact equal to 10b. And 10b is in fact the middle term that I'm looking for. So since positive 4b plus positive 6b is equal to 10b, it doesn't matter which box you put these in, but do keep the signs. That is the right combination of factors of 24b squared that will add up and give me 10b. Now at this point, what we're going to do, now that we know what those two are, is we're going to go back to step 1 and we're going to look for greatest common factor. But we're going to look for greatest common factor in 4 different directions. On the first one, we're going to focus on just this row. What is the greatest common factor between 3b squared and 6b? We see that both of these have a b, and that 3 will in fact divide into 6, so that greatest common factor is 3b. Then we're going to move on to the second row and look at 4b and 8, both of which are positive. There isn't a b in both of them, but 4 does divide into 8, so the greatest common factor is 4. Then we're going to go in the vertical direction, and we're going to look at this column and see what these two boxes have in common. And what they have in common isn't a number, because 3 and 4 have no common factors, but b squared and b has a common factor of b. There is a b in both. And then our last step is to look at the only remaining column. And of course, both of these don't have a b, but 6 and 8 can both be divided by 2. And it's a positive 2. So at this point, we just want to check and make sure that everything multiplied out. So we look at 3b times b, and we do get 3b squared. We look at 3b times positive 2, and we get 6b. We look at 4 times b and get 4b. And we look at 4 times 2, and we get 8. Therefore, the factors of 3b squared plus 10b plus 8 are 3b plus 4, and b plus 2. And we have now factored the expression. Problem number 3 says to solve the equation. And the equation we're given is 5t squared minus 45t is equal to 0. The first thing I would want you to recognize here is that 5t squared minus 45t is in fact a quadratic equation. And the reason it's quadratic is because the highest power is a 2. So that's a very important piece of information. Since it's a quadratic equation, the thing that I know about quadratics is that they are always equations of the form a times the squared term plus b times the term to the first power plus c, where c doesn't have a variable, c is just a constant. And if we set it equal to 0, and it doesn't have to be t, it could be ax squared plus bx plus c. But if we have that equation set equal to 0, and we do in fact have this one set equal to 0, then we can pick off the values of a, b, and c. In this case, a is equal to 5 for 5t squared. B is equal to negative 45 for negative 45t. And C is equal to 0. And to solve quadratic equations, the most efficient way to solve is with the quadratic formula. And the quadratic formula says that the variable, in this case t, is equal to the opposite of b plus or minus the square root of the value of b squared minus 4 times the value of a times the value of c, all divided by twice the value of a. And since we know what a, b, and c are, using the quadratic formula is simply a matter of doing a little bit of arithmetic. And of course, for the arithmetic, we're going to use a calculator to help us out. But the first thing we had to do was we had to identify a, b, and c. So we'll now substitute in a, b, and c and do the arithmetic. So to solve our quadratic equation, we have t is equal to the opposite of b. B is negative 45. Plus or minus the square root of the value of b, which again is negative 45, squared, minus 4 times the value of a, which is 5, times the value of c, which is 0, because we know here there is no constant term, so that would have been 0. And that's all divided by 2 times the value of a, which is 5. So now we're ready to do some arithmetic. And the most difficult part of the arithmetic is actually called the determinant, and that's the part of this formula that's underneath the radical. That's the most complication we're going to have. And notice that the only thing we're doing there to find that value is squaring a number and then subtracting the product of 3 other numbers. So we're going to use the calculator just to make it easier. And negative 45 squared, be sure you put that in parentheses, and don't forget that the negative sign is the negative sign, not the subtraction sign. And we're going to square that. And that comes out to be 2025. And from that, we're going to subtract 4 times 5 times 0, which you may not have needed to even put into the calculator, because you know 4 times 5 is 20, but 20 times 0 is 0. So this is really 2025 minus 0. And we come up with 2025. And the opposite of 45 is positive, or opposite of negative 45 is positive 45. Slide this up a little bit. And then 2 times 5 is going to be 10. So then the next piece of arithmetic that I need to do is I need to take the square root of 2025. So second x squared key to take a square root, and then 2025, and close my parentheses. And that comes out to be, of course, 45. 45 plus or minus 45 over 10. And then 45 plus 45 is 90. And 45 minus 45 is 0. Both of those are over 10. So that tells me that t is equal to 9 or t is equal to 0. And 0 is kind of a redundant expression, or a redundant answer here. But it is still a value because, of course, if t is equal to 0, then 5 times 0 squared minus 45 times 0 is 0 minus 0, which is, of course, 0. So 0 is a solution. But also, if I plug in 9, 5 times 9 squared minus 45 times 9 is also equal to 0. So that tells me that t could also take on the value of 9. And there are, in fact, then 2 different solutions. So when I'm ready to write my solutions in my math lab, be sure that you write your solution set as the set, and that's what those little wiggly brackets are. The solution set is 0 and 9. The comma tells you that that's 2 separate values. So you're typing the numbers as integers, and you're using a comma to separate your answers. Now, for those people that work this a different way, because a lot of people got this problem right, you could have solved this problem by factoring. And if factoring that expression gives you an obvious answer and you got the same answer I did, that's fine. But since not all quadratic equations factor, I chose not to solve this quadratic equation by factoring. My first choice is always to use the quadratic formula, unless it is obvious to me that a problem factors. Question number 4 is actually explicit that they want us to use the quadratic formula. It says use the quadratic formula to solve this equation and use a calculator to give solutions correct to the nearest tenth. So what we're going to do in problem number 4 is we're going to solve 5x squared equals 3 plus 6x. And they told us specifically to use the quadratic formula. And the quadratic formula is x equals the opposite of b plus or minus the square root of the radicand, which is b squared minus 4 times a times c divided by 2 times a. But we first have to have the equation in the form ax squared plus bx plus c. And our equation is not in that form. So the first thing we're going to do to begin to solve this equation is we're going to rewrite that equation by keeping the 5x squared where it is, and subtracting both of these terms from the other side. So that's going to be minus 6x and minus 3, which is going to leave me with 0 on the other side. And when it is in that form and it's set equal to 0, then I know I can use the quadratic formula to solve it. So now I know that my value of A is 5, the value of B is negative 6, and the value of c is negative 3. And I'll go back to the quadratic formula and plug that in. So x is equal to the opposite of b, which is the opposite of negative 6, plus or minus the square root of b, which is negative 6 squared, minus 4 times a, which is 5, times the value of c, which is negative 3. And that's all divided by 2 times a, which is 5. And the opposite of negative 6 is positive 6. And 2 times 5 is 10. So the only difficult arithmetic is going to be to find the radicand. And we will clear this off and multiply negative 6 squared minus 4 times 5 times negative 3. And the radicand is 96. And if I take the square root of 96, that doesn't come out even. So what I need to do to solve this problem is to first say x is equal to 6 plus, and it says round to the nearest tenth, but I don't want to round until the end, so I'm going to just simply keep that as the square root of 96 initially. And I'm going to put it in parentheses because I've got to divide this sum by the number 10. And then I'm also going to have to do the calculation for 6 minus the square root of 96 and divide that by 10 and get two different answers, both of which I will round to the nearest tenth. So here's how we're going to do that. Start off with the parentheses, 6 plus square root 96, close the parentheses in front of the 6, divide the answer by 10. And we get 1.579. And since we want to round it to the nearest tenth, that's going to be 1.6. And then we're going to repeat the same calculation, which you can hit your second and your enter button, and then just go back and change that addition sign to a subtraction sign. And we get negative 0.379. And that, of course, rounds to negative 0.4. So our solution set is 1.6 and negative 0.4. It doesn't matter which order you write those because it's just two separate numbers or two separate values for x. So our next problem says determine whether this graph is the graph of a function. An open dot indicates that the point does not belong to the graph. I'll just draw a quick sketch of number 5 so that I can explain to you why it is or isn't a function. So what we have here is from here to here, we have that x has a constant value, whatever that value is. And at this point, it jumps up to be a higher value and continues on until it changes behavior again. And here, it actually jumps down to actually having an output that's negative but it began with a different number. And then same thing here. And just for the sake of argument, just for the sake of making this an easier problem to discuss, that's your domain value. And these are your range values. And I'm arbitrarily, even though the graph does not specify it this way, I'm going to arbitrarily say that this is 1, 2, and this is -1, -2, -3. So we can just kind of refer to actual values. And in this case, that would be 2, and this would be 1. This would be -1, and this would be -2. Now, a lot of you are going to try to just go ahead and apply the vertical line test. And the vertical line test does work, but you need to understand why it works. Vertical line test says that this is the graph of a function as long as if I draw a vertical line anywhere on the graph, I only cross it one time. So for example, here, if I draw a vertical line through x equals -3, for the x value -3, I am going to be assigned in my little world I designed the value -2. And for everything between -3 and -2, that's going to be true. Because even if I draw a vertical line here, I cross the graph once, and I cross it at -2. The definition of a function says for every value of x, in the domain, the domain is all of the basket of values that you get to pick from for your function. If this is a function, there is one single unique value for the range. So the thing to remember here is this is your domain values, and these are your range values. You pick a value out of the domain, and it matches to a single value in the range if what you have is a function. So the first question you're going to come up with is there a place where you look and you see, maybe there's two different y values that goes with a single x? For example, what happens here at -2? And at first, if you're not looking carefully, you think, well, at x equals -2, the y value is both -1 and -2, but that's not true. It's not true because there is what we call a hole in the function on that first piece. So the vertical line test basically tells you that anywhere you draw a vertical line, if you have one single unique y value, which we had here, then you have a function. And the only suspect places on this graph are going to be where the graph changes behavior. For example, here at -1. But again, here at -1, we have a solid dot indicating the value at -1 is actually 1, not -1, -1, because that's where the hole is. And the same thing is true at the value x equals 1. At the value x equals 1, when x is 1, the value of the range is 2, not 1, 1. So yes, this is a function. But not because it passed the vertical line test. This is a function because for each domain value, and you can refer to that as the x value because that is the way the graph identifies. There is one single unique range value. So this is, you can just answer the question, but if I were to ask you this, I would ask you to justify your answer, and you would need to tell me, explaining it in the context of the value of a function. So I would be looking for this idea. I need to know that you understand why it is a function. And now that we've discussed domain and range, we can talk about finding the domain of a function. Number 6 says find the domain of g of x, which is the rational expression 2 minus 9x. And at this point, we need to remember that there are 2 cardinal rules in mathematics, 2 thou shalt nots. The first one is divide by 0. Not allowed. The second one is take the even root, and I'm being very careful here saying the even root. That would be things like square root or fourth root or sixth root of negative numbers. Okay? Not allowed to do that either. And it's important to realize that that's just even roots. The odd roots of negatives is okay. Like, for example, the cube root of negative 8 is negative 2. Because that, if you have an odd number of negative signs, the answer comes out to be negative. So we're wanting to find the domain in this case. Now, since we don't see any radicals, we don't have any worries about that. But we do have this concern because this is dividing into the 2. And we have to be careful about that because whatever 2 minus 9x is, it is not allowed to be negative. I'm sorry, it's not allowed to be 0. So that rule, that part of the thou shalt nots, tells us that 2 minus 9x is not allowed to be 0. That cannot be allowed to happen. And if we don't allow that to happen, then that means that 2 cannot be equal to 9x, which means that x cannot be equal to 2 over 9. That is the exclusion. And the way they wrote the language here in the multiple choices is it's not at all hard to figure out which one is right. They just simply wrote it in what is called set notation. And the first one, it says that x has to be equal to or greater than 2/9. Well, no, because if x is equal to 2/9, then we have an undefined expression because it says specifically here x can't be equal to 2/9. If x were 0, we would simply have 2 minus 9 times 0, which is 2 minus 0, and 2 over 2 is 1. So that's not a problem. That says that B is not the right answer. It says in D that x can be any real number except 2. Well, 2 minus 9 times 2 is 2 minus 18. 2 minus 18 is negative 16. 2 over negative 16 is negative 1 over 8. That's not a problem either. So the correct answer is C. X is a real number and x does not equal 2 over 9. So that takes care of that one. So in number 7, we're looking at a graph. This is the graph of the function h of x is shown. Find the function values h of 1. Okay, on this graph, we have here from negative 10 to 0 to 10. The value x is equal to 1 is right there, and the point that corresponds to this is the point right here, which is where y, which is the same as h of x, is equal to 1. So the value when x is equal to 1 is the y value of 1. So just a quick sketch of the function that we're looking at here. H of 1 is, we look to see where x is equal to 1. We see that the point is at 1, 1. So h of 1 is equal to 1. H of 3 is where x is equal to 3, which is that point at the very top. And we see that h of 3 is 1, 2, 3, 4, 5. Or on the graph, to make sure that I'm matching, I'm going to go, okay, there's 3, 1, 2, 3, 4, 5. So h of 3 is equal to 5. And then h of 4 is at the point 4, 1. So h of 4 is equal to 1. So now we'll move on to number 8. And number 8 says, given that g of x is equal to x minus 6, divided by x plus 7. They want us to find various values of that function. So they want to find g of 8, g of 6, g of negative 7, g of negative 12.75, and then the last one is g of h of x, or x plus h, I'm sorry. Now, I'm going to actually do the arithmetic for the first three, or I'm sorry, for the first four, and then I'm going to back it up on the calculator. I'm going to show you a nice way to check on the calculator. So g of 8 is equal to 8 minus 6 over 8 plus 7, which is 8 minus 6 is 2, and 8 plus 7 is 15, and the answer is 2 over 15. And 2 over 15 is a fraction that does not simplify or reduce. Plugging in 6, I have 6 minus 6 over 6 plus 7. 6 minus 6 is 0. 6 plus 7 is 13, and 0 divided amongst 13 is still going to be 0. That's like saying, well, if you have nothing and you have 13 friends, you and your friends can divide up your nothing, and they all get nothing as well. So that's okay. We can have that. If x is negative 7, we have negative 7 minus 6 over negative 7 plus 7, which gives us negative 7 minus 6 is negative 13 over negative 7 plus 7 is 0. Can't divide by 0. That is undefined. And that's the way that you would answer that. It means it's not a real number. Negative 12.75 is a little bit more trouble because there's a decimal included. Negative 0.75 minus 6 over negative 12.75 plus 7 will give me minus 18.75 over negative 5.75. And in this case, I can reduce the fraction. Positive over, or negative over negative is going to give me a positive answer. And it looks to me like I can divide both of those by 25. So I'm going to try that. That's going to give me 0.75. And then 575 divided by 25 gives me 0.23. And those don't have any more common factors, but I could remove the decimal by moving the decimal 2 places to the right in both and getting 75 over 23. And just to make sure it doesn't reduce, I'm going to say 75 divided by 23, math, fraction, enter, and it comes back with the same thing. So I know that is the answer in lowest forms. So here's what we can do to actually check our arithmetic without having to re-enter these expressions a whole bunch of times. I'm going to go to the graphing window, the y equals window, and clear out what's there. And I'm going to enter in the expression for g of x, which is in the numerator x minus 6 in parentheses divided by the denominator, which is in parentheses x plus 7. And there's a couple of different ways I can actually do this. The first way would be to use the table. So we're going to go to the table setup and ask for independent variables, which is your x variable, and go to the table, and we're going to enter in first 8. And it says 0.1333, and I'm not sure if that's right, but if I want to check that out, I got 2 over 15. Well, guess what? That is 0.1333. But I would enter the fraction. Going back to my table, what about if it's 6? It says the answer is 0. Great, that's what I got. What if I put in -7? It says there's an error. And that's all it tells you, is there's an error. Well, we know the error is that it's undefined. It's not a real number. But if I go back and I need some help from my calculator, if I go back to my home screen and I say vars, yvars, function, y1, remember what's in y1 is that expression. So if I put in parentheses after that expression -7 and hit enter, it tells me the error was because I was trying to divide by 0. Okay? So it actually tells you why it's not a real number. You're dividing by 0. And then on the -1.25, I can do the same thing here. I'm sorry, -12.75. So just in place of the -7, I can enter -12.75. And it gives me a decimal answer, but I can change that decimal answer to a fraction. And it tells me in lowest terms that that fraction is 75 over 23, which is exactly what I got. So for there, the calculator can help me out quite a bit. But the calculator is not going to help me out at all with the last part. Because with the last part, I actually have to do algebra because x plus h is not a number. So the original expression was g of x is equal to x minus 6 divided by x plus 7. And in place of x, I need to plug in x plus h. So g of x plus h is equal to x plus h minus 6 over x plus h plus 7. And that is what you need to actually enter in to MyMathLab. It is an expression. And you're going to have to actually type that expression in that box. You cannot simplify that expression. Do not try to cancel those two x's. Do not try to cancel those two h's. These are individual terms. You cannot cancel a term into another term. If you can't factor the numerator and factor the denominator, which here you can't, then there is no cancellation possible. So do not cancel. Those are terms. You can't cancel terms. If you can't factor, you can't cancel. Here we're given another function. And since all of the inputs here are numerical inputs, I'm going to choose to put this function in the graphing calculator and get answers. So rather than write anything on paper, I'm going to go to y equals, and the numerator of this function is just simply x. You can put it in parentheses or not, doesn't matter. And the denominator of this is a square root, and under the radical we have 4 minus x squared. If you have an 83 and some of the earlier 84s, you'll need to enter it just exactly that way. Some of the 84s that enter things as fractions won't have you have to have actually the 4 minus x squared in parentheses. But if it does, your 84 should extend the top of that bar all the way over your 4 minus x squared. It never hurts to have the parentheses. So the first thing it asks us to find is g of 0. And I'm not going to use the table this time because when it comes to putting in 1/3, I'm going to need to get a fractional answer out. So I'm just going to do it from the home screen. So second vars is your variables key. I'm sorry, not second vars, just vars. Vars is your variables key. And your y variables are a right arrow function, and the very first one is a function, and g is in fact a function. So we're going to choose function, and we put it in y1. So remembering that y1 has our expression in it, all we need to do then is in parentheses after y1, which looks very much like function notation, first of all we're going to enter in a 0. And of course, if you plug in 0 for x in both of those, you've got 0 divided by 4 minus 0 squared and square root it. Well, 0 divided by the square root of 4 is 0. So the correct answer there would be A. If we go to vars again, and I'm going to, even though I could use second enter, I'm going to keep doing vars to get you reminded of how you can get your y1. So y1 of -2. It says you can't do that. You're going to divide by 0, and that's because if you put in -2 and square it, you get 4 minus 4 under the radical. The radical doesn't care it's 0, but the square root of 0 is 0, and you can't divide 0 into -2. So that one is not a real number. Our third one is going to be g of 1/3, 1 divided by 3. And we're going to need to put the answer in. Oh, I'm sorry, I'm ahead of myself, but that's okay, we'll go ahead and do it. We're going to have to put the answer in, and it says simplify your answer, type an exact answer using radicals as needed. Well, if we try to plug it in here, if you just hit enter at this point, you get a decimal. That's no help. If you try to change it to a fraction, you get the same answer. That doesn't help. So when we get to that part, we're actually going to have to do that one ourselves. But the other one was g of 4. And I'm going to have it, I'm going to ask it as a fraction, even though it probably shouldn't need to be a fraction. And it says it's a non-real answer. So I'm going to need to investigate g of 4 and g of 1/3 further. So we are going to do those over here on the side. So here's g of x. So we're going to need to find g of 4. And then down here we're also going to need to find g of 1/3. So let's go about doing that by hand to see why we got what we did. So g of 4 is going to be 4 over the square root of 4 minus 4 squared, which is going to be 4 over 4 squared is 16, and 4 minus 16 is negative 12. And there's where our problem is. You are taking the even root of a negative number, which gives us a non-real answer. It is not a real number. So the choice there is not that g of 4 doesn't exist, which would be division by 0. It is that it is not a real number. Now let's check out why we got the answer we did for 1/3. For 1/3, x is equal to 1/3, so that's 1/3 divided by the square root of 4 minus 1/3 squared. First thing we're going to do is we're going to focus on what 4 minus 1/3 square is. So that's the square root of 4 minus 1/3 times 1/3 is 1/9. Okay. So that's going to be 1/3 divided by the square root. Let's see what 4 minus 1/9 is. The calculator can help us with that. And I want the answer to come out as a fraction. It says that's 35 over 9. Now, one of the things you need to remember, and keep in mind, I'm just ignoring that 1/3 in the numerator right now. One of the things that you need to keep in mind is that when you have square roots that are square roots of a fraction, one of the things that you can do is break up the square root sign and put it separately over the numerator and the denominator. So I now have the square root of 35, and the square root of 9 is 3. But the problem I'm running into here, and it's not one that I can't solve, but it is something that you're going to have to remember how to deal with it. The issue here is, what the heck am I supposed to do with this? Because I'm trying to divide this quantity by this quantity, and I could put that straight into my math lab and it would tell me I didn't simplify it. So how do I simplify that? Well, here's the thing. A fraction is a way to write a division problem. This is divided by the numerator divided by the denominator. So I'm going to rewrite that as a division problem. And if you remember anything about working with fractions at all, the way that you work a division problem with two fractions is you keep the first fraction the way it is, but you flip the second one over and multiply by it. And when we do that, we have 1 times 3 over 3 times the square root of 35. And what actually happens in that case is that those 3's cancel, leaving us with a 1 in the numerator and the square root of 35 in the denominator. So the correct answer for this and it says type an exact answer using radicals. The correct answer would be 1 over the square root of 35. And that will take care of that problem. So now we have problem number 10, and this is called composition of functions. So let me talk to you a little bit about what this means. When we're trying to find f of g of -1, sometimes that's also written as f with a little circle and then g and then the -1 after it. And that is not a multiplication symbol. That's just simply two different ways to write the same thing. But what that's telling you to do is it's telling you to use the output from G as the input for X, for F. So the first thing I need to do is I need to use the rule for G and find G of -1. And the rule for G says take whatever X is and square it and subtract 5 from it. So that means that G of -1 is equal to 1 minus 5, which is -4. So I'm going to take G's output, which is -4, and use it as the input for F. And what F does is it takes X, which is -4, and it subtracts 1 from it. So f of g of -1 then is equal to -5. So it's a matter of paying attention to which rule you use when. And in number 11, they've simply chosen to use the second notation. So in number 11, we have f of x is equal to -4x minus 1. So what f does is it takes whatever x is, multiplies it by -4, and then subtracts 1. And it says h of x is equal to x plus 2 over 3. So what h does to x is whatever x is, it adds 2 and then divides the total by 3. And they want us to find what's called the composite, which is f of h of 3. Which means the same thing as taking f and using the output of h of 3 as the input. So the first thing we need is h of 3. And that turns out to be 5 over 3. So then f of 5 over 3, and I said 5 over 3 and wrote 5 over 5. Sorry about that. F of 5 over 3 is equal to negative 4 times 5 over 3 minus 1. And negative 4 times 5 is negative 20. And 1 times 3 is 3 minus 1. And since we're trying to subtract fractions, negative 20 over 3 minus 1 over 1 written in thirds is 3 over 3. And negative 20 minus 3 is negative 23. And if you want to check that one on the calculator, it's actually pretty easy to do that. Since your function is negative 4 times x times 1, and x is a fraction, I'm just going to do that from here. Negative 4 times 5/3 minus 1. Change the answer to a fraction, and I get negative 23 over 3. Number 12 is a multiplication problem, and so is number 13. And when I teach these same problems in my class, I use the multiplication box that I used when we were factoring. So I'm going to show you how to do it that way, and maybe it will help you understand why the factoring boxes work and why they're so efficient. So number 12, I'm going to multiply 5b minus 5t times 5b plus 4t. And yes, I'm aware that you can use the FOIL process on this, but that process confuses some students. So for those of you that are confused by the FOIL process, I'll show you how to do this without using the FOIL method. What we do is we're going to build a multiplication table. So what we're doing here is we're multiplying. We have 5b minus 5t. And I wrote them so that I can separate the two terms into each having its own box. And then 5b plus 4t. So in the process of the FOIL here, those of you that know about FOIL, this is the F, this is the O, this is the I, and this is the L. First times first, inner times inner, outer times outer, and last times last. That's the way this process works. It matches up with FOIL. It's just organized a little differently. So when I do this multiplication, 5b times 5b is 25b squared. Negative 5b times positive 4t, I'm sorry, negative 5t times positive 4t is negative 20t squared. 5b times 4t, 5 times positive 4 is plus 20, and b times t is bt. Negative 5t times positive 5b, negative 5 times 5 is negative 25, and b times t is bt. Here is your two middle terms. And those two middle terms combine 20b plus negative 25bt is negative 5bt. There's your middle term. Your first term is 25b squared Your last term is minus 20t squared. And so that's your final answer. And it doesn't take any more time than doing the FOIL method. So to practice here with number 13, says to multiply 2b minus 5 and it doesn't matter if you start on the side or the top, times 2b plus 5 so again 2b times 2b, 4b squared, negative 5 and positive 5 makes negative 25, 2b times negative 5, negative 10b, 5 times 2b, positive 10b, negative 10b, plus 10b, 0b. There is no middle term. The b's disappeared. So your final answer then is 4b squared minus 25. There's no need to write down that 0b. Our last one, and this is going to be a big caution, so I'm going to turn this upside down and adjust a little bit because there's a mistake that's really common to everybody that tries to do this problem. So I'm going to try to get you to avoid making this mistake. I'm going to make you the caution, first of all, that in number 14, r plus 6 squared does not equal r squared plus 6 squared. That is not what that means. Please do not make that mistake. That will make me very, very sad. Because you should know that that is not what that means. What that means is r plus 6 times r plus 6. R plus 6 squared is just a shorter way to write that. So the way that you do that problem is exactly the same as the way you multiply any other pair of binomials. R plus 6, r plus 6. R times r squared. R times 6, 6r. 6 times r, 6r. 6 times 6, 36. Here's your two middle terms. Plus 6r plus 6r combine to give us plus 12r. Your first term is r squared. Your last term is 36. That is the correct answer, and that is the correct method. Please don't be the one that tells me that this is true, especially on a quiz or a test. Please commit that to memory right now. Now we're on to factoring. Number 15 says to factor, and if it can't be factored, write prime. And the caution here is factor out the greatest common factor as necessary. If you don't do that, you're going to wind up with something that is not completely factored. So step one is also always to try to find the greatest common factor. So what we have here is the polynomial 6 b to the third power minus 18 b to the second power minus 420 b. And our first step, step 1, is to find the greatest common factor. And what we see immediately is that all three of these terms have a b. So you look for a common variable and find the lowest power of that common variable. Now, there's a lot of different ways to find the greatest common factors of three numbers. The first thing you want to do is you want to ignore the signs of the numbers because you're actually only looking for the numerical factor. And if you're not aware of this, your calculator actually has a built-in routine. You can go to your math menu to the numerical part, and there's actually two things here, number 8 and number 9. Number 8 is the lowest common multiple, and number 9 is the greatest common divisor. What we would actually like to know here is what is the greatest common divisor of all three of these numbers. So we're going to choose that one. And the problem with the greatest common divisor is you can only go two numbers at a time. So we're going to start out with 6 and 18. Now you may already know the answer to this, but learning how to use this feature on your calculator is going to be a nice thing to know when you have larger numbers like 420 and 3,027,000. So you want to figure out how to use this. So we're going to start out with 6 and 18. We know that the answer is 6. So we're ignoring the signs. This is the greatest common divisor, which is a factor in this case, is 6. Then we're going to look for the greatest common divisor between between 18 and 420. And it says that's also 6. So the greatest common divisor for all three of those numbers is 6. And of course 6 divided by 6 is going to give us 1. 18 divided by 6 is going to give us 3. And since it's negative 18, it's going to be negative 3. And the only one you might not know right off the top of your head is the 420, but you can use your calculator right here and divide 420 by 6 to see that it's going to wind up being 70. And again, because negative 420, it'll be negative 70. So your greatest common factor is 6b. Don't lose that. But 6 goes into 6 one time, and b over b cubed is b squared. 6 goes into negative 18 minus 3 times, and b squared over b leaves us with b. And 6 goes into negative 420, negative 70 times, and the b's, of course, in this case, cancel out completely. So now the question becomes, can I factor the trinomial that I'm left with after I factored out the greatest common factor? And the thing you want to remember here is you want to keep the GCF. We haven't gotten rid of it. We haven't thrown it away. It's still part of the problem. But we need to keep the GCF, which is 6b, but factor the trinomial. So as we factor the trinomial, I've showed you before, we know that trinomial used to be the product of two binomials. And the first times the first gave us b squared. And the last times the last gave us negative 70. What we don't know is what is going to give us the negative 3b. We've got to find that negative 3b. And that tells us, because it's negative, that we're going to have probably one bigger than the other to get a negative answer, or that we're going to add together two negatives. So we look and say, okay, whatever this factor is going to be, it's going to have to be some two factors of negative 70b squared. So we'll talk a little bit about what we know about negative 70b squared. First of all, its factors, if this is a negative product, one of those factors is positive, one of those factors is negative. And it could be that the smaller factor is positive and the larger is negative, or the smaller is negative and the larger is positive. But since when we add these up, the result is going to be a negative number, that means that the littler one is going to be the positive number and the bigger one is going to be the negative number to get a negative result. So we know there's going to be a difference of signs. We also know that in order to get b squared, we're going to have to be multiplying a number in front of b times a different number in front of b. So there's a lot of ways to get 70, and the first one, again, is the obvious one, and these are going to be the positives, and these are going to be the negatives. First one is 1, and of course 1 times 70. So that's 1b minus 70b, and obviously that's not what we want. That's negative 69b. That's no help. But then you can divide by 2. 2b times 35b, if the negative is the negative 35, positive 2b times negative 35b gives us negative 70b squared. And when we add these together, we get negative 33b, which is not going to be the right answer, and we know that. But we keep trying. At this point, you may hit the calculator if you want to, just to make sure that you can't take 70 divided by 3. And you can't. It doesn't work. 70 divided by 4 didn't work because it comes out to be a decimal. But 70 can be divided by 5, and the other factor is 14. So that tells us that if we take 5b, which is positive, times negative 14b, that would give us negative 70b squared, and when we add them together, we get negative 9b. We're not there yet, but we're getting close. Now, if you couldn't divide it by 3, you're not going to be able to divide it by 6 either. And you can divide it, however, by 7. So 70 divided by 7 is going to give us 10. So we've skipped 6b because it didn't work, and we're going to go to 7b. Positive 7b times negative 10b is negative 70b squared, and guess what? When you add them together, you get negative 3b. That's the one we're looking for. So we have a positive 7b and a negative 10b, and it doesn't matter which one goes where. We fill in the boxes with our two unknown factors that we now know. And now we're going to go back to the GCF process. Greatest common factor across this row, there's a b in both of them. Greatest common factor among the second row, that's going to be 7. 7 goes into 70. Oops, just 7, not 7b. Then we're going to go up the first column. The greatest common factor between b squared and 7b is b. And then we're going to go up the second column. There's no variable in common, but negative 7 and negative 10 have a negative sign in common, and 10 divides into both 10 and 70. So now's the time that we need to determine what the sign is on this 7. and to check and make sure that we've done everything correctly. So b times b does give us b squared. 7 times negative 10 does give us negative 70. B times negative 10 does give us negative 10b. So then 7 times b is positive 7b only if this 7 is also positive. So that means then that our factors are b plus 7 and b minus 10. And that tells us that the original problem completely factored is equal to 6b, don't leave out your greatest common factor, times b plus 7 times b minus 10. And just as a point of clarification, I want to explain to you why it didn't matter where I put those two. We knew b squared went there. We knew negative 70 went here. We did all of this, and we wound up knowing those were the right two terms for these two boxes. I didn't have to put 7b in the bottom box. I could have put it here. And then I would have put negative 10b down here. And if I had done that, the greatest common factor across the top row is still b. The greatest common factor across the second row is now negative 10. The greatest common factor among the first column is b, and among the second column is 7 and negative 70 is going to be 7. And I don't know whether it needs to be positive or negative. But I'll figure that out as I multiply out and check. B times b is b squared. Negative 10 times 7 is negative 70. Negative 10 times b is negative 10b, and the only way that I'm going to get 7b by multiplying b and 7 is if that 7 is also positive. So I still have the same two factors. So that's why it really doesn't matter which two boxes you put those two factors in. You can put them in either set of boxes as long as you remember you factor this way, this way, this way, and this way. You'll get the right set of binomials. Okay, now we're ready to factor another one, and we're going to use the same method. So number 16 says to factor v squared minus 64. And the first thing that I would hope you notice is there is no common factor. So we're not going to be able to do that step. If you memorize the little issue about that you have the difference between squares, and you can factor this one without using my box method, please don't try to use the box method if you don't need to. But in this case, some people don't recognize difference of perfect squares and they need to have that backup method. And the backup method still works. So step one was there is no GCF, so we need to factor this. The thing is, though, what we're used to seeing is we're used to seeing it with a middle term. Well, put the middle term back in. Just give it a 0 coefficient. So once we've done that, we know that the way that we're going to factor this is just like any other trinomial. It's going to factor into two binomials. So the v squared is going to go in the first box, and the negative 64 is going to go in the second box. But these two boxes here are going to have to add up to plus 0, v. So we go and say, okay, we have negative 64v squared. It's negative, so we know that one sign is going to be positive, one sign is going to be negative. And if they're going to add up to 0, it really doesn't matter which one's which, because it's going to have to be that they add up to 0. It means they're going to be the same thing, the same number, but different signs. But we're going to proceed the way we would have to begin with. 1v times 64v, which obviously, regardless of how I arrange the signs, is not going to give me a 0. 2v times 32v multiplies outright but doesn't give me a 0 in the center. 3 actually doesn't work. You can verify that on your calculator. 4v is multiplied with 16v because 4 times 16 does give us 64, but obviously again does not add up to 0. 5 doesn't work because it doesn't end in 5 or 0. 6 will not work because 3 didn't work. 7 actually doesn't work either, but 8 does. 8 times 8 is in fact 64. And as long as one of the 8's is positive and one of the 8's is negative, then this indeed does give us 64v squared, that is negative, but it also gives us 0v, which is what we're looking for. So one of the boxes has 8v, one of them has negative 8v, and the one that I didn't put a sign in, remember, that's going to be positive. So the greatest common factor here is going to be v. The greatest common factor here is going to be 8. The greatest common factor here is going to be v, and the greatest common factor here, since both of these is negative, is going to be the negative 8. And of course you're going to figure out quickly that in order to get negative 64 here, you have negative 8 and positive 8. So when you factor v squared minus 64, you get v plus 8 and v minus 8. Now, those of you that have that little trick memorized because you recognize perfect squares, you're already done with this problem. But this just reinforces what the process is for those people that have trouble with that. Our next problem says to solve an equation by factoring. And we did a problem similar to this, and I had you do it by quadratic equation. But for the sake of those people that say, well, you know, that would have factored and I could have solved it that way, well, you're right. It does, and you could. So solve this equation by factoring. Well, we first have to factor this part of the equation. There is a common factor of v. And 5 does go into 45. And 5v into 5v squared leaves us with v. And 5 goes into 45 negative 9 times. And those v's cancel, is equal to 0. And when you solve using factoring, you're relying on something called the zero product principle. Or the zero product rule. Principles and rules in mathematics are the same thing. Basically, it says A times B is equal to 0 only if either A equals 0 or B equals 0. In other words, this times this can only come out to be 0 if either 5v is equal to 0 or if v minus 9 is equal to 0. Well, if 5v is equal to 0, that means v's got to be 0. Because the only way 5v is going to be 0 is if 5 times 0 is 0. If v minus 9 is equal to 0, that's only going to happen if v is equal to 9. So your two solutions are v equals 0 and v equals 9. And there's your answer. Now we're going to start talking about slopes and equations. Slopes and rates of change are going to be very important in calculus, so you're going to need to remember how to find slopes of lines. That's going to be a process we're going to depend on quite a bit. So starting with number 18, find the slope of the line if it is defined. Remember, division by 0 is not defined. So starting with these 2 points, you have memorized slope is rise over run, or some formula about x1 and x2. The only thing you really need to remember about slope, how you find slope, is that it's the difference in the y's over the difference in the x's. And the slope formula, actually, most of the calculus books use this representation. And that little triangle simply reads the difference in the y values and the difference in the x values. And difference indicates the subtraction. The key thing to remember is that you have to keep your points lined up with each other. You can't break up partnerships. So the point -3, 5, the x value is -3, the y value is 5. The point -5, 10, the x value is -5, the y value is +10. And here I'm trying to subtract a negative, so I'm going to put -5 in parentheses to emphasize that. Now, it won't make any difference which one of those I put first. I can start with -5 and 10. And I can end with -3 and 5. And again, I'm going to put subtracting negatives in parentheses. And what I'm telling you here is as long as you keep the coordinates of your points together, it doesn't matter who gets to be first and who gets to be last. 5 minus 10 is -5. -3 plus 5 is +2. 10 minus 5 is +5. -5 plus 3 is -2. But in either case, my slope, since I have a negative over a positive or a positive over a negative, my slope is negative. And its value, its absolute value, is 5 over 2. So that's the correct slope. Please be sure you learn that process. That's a very important process. So my next problem says to find the equation in slope-intercept form for this line. And slope-intercept form means the form of the equation we're looking for is y equals the slope times the x value plus whatever the y-intercept is. Okay? So here's the information that we've been given. It is through the point 1, 6. And it has a slope of negative 5. And I'm going to use y equals mx plus b. Well, I've got m right here. What I have here is an x and a y value. The only thing I don't know is the value of b. Now, there is a point slope form that will lead you to the same process, but is actually longer than what I'm going to show you. The only form you actually need to know is the slope-intercept form. So given that y is equal to 6 and m is equal to negative 5 and x is equal to 1, the only thing I still don't know is b. And that's an actually very, very easy problem to solve because negative 5 times 1 is negative 5. So 6 equals negative 5 plus b. And if I add 5 to both sides, I very quickly see that b is equal to 11, which means that my equation is y is equal to the slope, which is negative 5, times x plus the y-intercept, which is b, which is 11. So my equation is negative 5x plus 11 is equal to y. Now, number 20 isn't much more difficult. The only difference is in number 20, I first have to find the slope. So what I'm given is 2 points on the line. Three, 4, and 1, 7. And I need to find the slope because I'm looking for y equals mx plus b. So my slope, once again, is the difference. Doesn't matter which comes first. Just be sure you put your x's on the bottom. Those have to go on the bottom. Your y's go on top. So 7 minus 4 is 3, and 1 minus 3 is negative 2. And my slope is negative 3 over 2. So now I know m is equal to negative 3 over 2. And I can choose either point that I want to. It doesn't matter which point you choose. My x value for 1, 7 is 1, and the y value is 7. And I'm going to plug that into y equals mx plus b. So y is equal to 7 is equal to the slope, which is negative 3 halves, times x, which is 1, plus b. Negative 3 halves times 1 is negative 3 halves, plus b. 7's on the other side. Let's add 3 halves. And that tells me that b is equal to 7 plus 3 halves. And I'm going to change that into a fraction so that I can use b as a fraction. Turns out to be 17 over 2. So that tells me then that my equation that I'm looking for is y is equal to negative 3 halves times x plus b is 17 over 2. And it says you can use integers or fractions in the equation. So that's why I chose 17 over 2. If it had come out to be a whole number, an integer number, then I wouldn't have had to change to a fraction. But just in case it was a fraction, that way I know that it was a fraction. Number 22 says to estimate the slope of the line given to the right. All you have to do when it comes to estimating a slope is to be able to pick out a couple of nice points. For example, I'm pretty sure this point right here on this graph is 1, 1. And to get to the next point on the graph, I can count up 1 and over 1 and know that the next point is 2, 2. You can see that that's 2, 2. And if I go up 1 and over 1, I get the other point on the graph, which is 3, 3. And if I count up 1 and right 1, that gives me 4, 4. So the slope of the line is up 1, which is positive, and right 1, which is positive. So the slope of that line is 1. 1 over 1 is equal to 1. Now we need to graph the linear equation. And I'm not going to help you out with the graphing tool except to tell you that as long as you get the right line, it doesn't in this particular situation matter what points you choose to use. So I'm going to show you a couple of different ways to do this. Then I'm also going to show you a way you can check and make sure you're getting it right, because that's always important too. So, graph the linear equation. Four x minus 12y equals 12. Well, to graph 4x minus, 12y. I put 12y and that is not correct. Let me at least start from the right problem. 4x minus 2y equals 12. If you have an equation in standard form, the easiest way to graph that equation, if you're going to do it by hand, is to find its x and y intercepts. So that's what we're going to do. To find its x-intercept, choose y equals 0. So that means you have 4x minus 2y equals 12, and you've chosen y to be 0, which means that disappears because negative 2 times 0 is 0. So that means 4x is equal to 12. And that means x is equal to 3. And that gives you the point 3, 0. To do the y-intercept, you choose x to be 0. And when you choose x to be 0, this disappears because 4 times 0 is 0. And what you have left is negative 2y equals 12. And that means y is equal to negative 6. So when you're trying to graph that, what you're going to do is you're going to start at 3, 0. Means you go right 3 and stay on the x-axis because that's your x-intercept. And then on the y-axis, you're going 0, negative 6. So you plot those 2 points. And you get a ruler and you draw a straight line. My ruler isn't handy right this minute. But you draw that straight line, and there's your graph. Now, if you want to verify that on the calculator, you want to make sure you didn't mess up. And, you know, a lot of times there's comfort in knowing that you're right. We can go to the graphing calculator, but it's you have to pay attention to the way I'm going to have you do this, because I'm not going to make you solve that equation for y the way you at one point probably had to do it. I'm going to let you take a shortcut. So I'm going to go to the y equals menu, and I'm going to clear out y1. And what I'm going to do is I'm going to subtract 12 minus 4x. That gets the x's on the other side. And then what I need to do then to get the y by itself is to divide that whole expression by negative 2. And then since my graphing window that they're showing me here goes from negative 10 to 10 in both directions, the calculator has a built-in window for that. It's called standard number 6. And you can verify here that that is negative 10 to 10 in both directions with a x scale of 1. It's going to put a tick mark for every number. And your graph looks like this, which, you know, looks pretty much like what I sketched on the paper. If you want to verify that those points are correct, what you can do is hit your second trace button and get your calc menu and say when the x value is 0, what's the y value? And it says, well, it's 0, negative 6. Great, because that's the right point. And if you want to verify that that actually is for sure 3, 0, you can do the same thing. Second trace, choose value, and say, show me where x is equal to 3, and it shows you that that's the x-intercept, 3, 0. So without going through this again, even though you can, I'm going to use that method and graph the equation 7x minus 4y equals 28. So I'm going to go back here to my y equals menu, and I have 28 minus 7x, not 4x, and the number in front of the y this time is -4. And again, they're showing me the standard window. So I'm going to go zoom 6. And it looks like my x-intercept is 4, 0, but if I want to be sure, I can ask it to show me, and it says that it is 4, 0. And if I want to know the y-intercept, that's always going to be where x is equal to 0. So my y-intercept is 0, -7, and that's enough information for you to graph it on the screen. Number 25 says to determine whether y is a function of x. And the thing that you need to remember here is that the definition of a function says for each x value, there is one single unique y value. It doesn't matter if y has two different x's. It only matters if x has two different y's. So the first thing you want to do here is look at your x values. And I've got 5, 3, 1, 0, -1, -3, -5. Well, all of those are different. So it doesn't matter that 5 maps to 25 and -5 also maps to 25. That's a repeated y value that goes to different x values, and that's just fine. 9 can go to 3 and -3 because 9 is the partner for x. These are different x values. So as long as your x values aren't repeated, then this is a function, and your answer to that question is yes. Number 26 says give the domain and range. On number 26, the domain is your x values. Now, if this function had an arrow on this end and an arrow on that end, I would have to say that the domain was all real numbers. But this function doesn't go to infinity in the x positive direction or negative infinity in the x negative direction. Its lowest x value is -2. And its highest x value here is +4. So because its beginning point is the number -2, 0, and its ending point is the number 48, or the point 48, and I'm talking about domain, I'm only talking about those x values between those 2 points. So its domain is all of its x values, which in this case is all real numbers from -2 to +4. And you're going to write that as an interval, and in interval notation, since this point was a solid dot and this point was a solid dot, it says those 2 points are included. in the domain. So that means you include -2 and you include 4. And that's because x actually starts out being x equals -2 and it ends where x equals +4. So associate your equal signs with your squared off bracket. If those had not been included, we would have used parentheses instead. Then the other thing that it tells us is to find the range. The range is all the y values. So when we're looking at the y values, the lowest y value is 0 and the highest y value is 8. And notice that even the point 20 doesn't go lower on the y-axis than 0. If this part had gone lower than that, then that would have been a problem. And that this value of 8, when x was equal to 0, the highest y value once again was 8. So that's still the highest y value. So the lowest y value here is 0. And the highest y value is 8. And again, those two values are included because that point is a closed-in circle. Then it says find f of -2. That means you start on the x-axis and go to where x is -2 and see that the y value there is 0. So this would have been the number 0. F of 0 says let x be 0. Determine what the y value is, and that would be 8. So the answer to part B is 8. F of 1/2. 1/2 is about halfway between 0 and 1. So giving your best estimate, going straight up from 1/2, it appears that that's about 6. So f of 1/2 would be approximately 6. And then the last question says, what are the values of x where f of x is equal to 4? Well, the graph equals 4 here, which comes from the x value -1. It equals 4 here, which comes from the x value +1. And it equals 4 here, which comes from the x value 3. So the answer there is going to be -1, +1, +3. Now we're going to talk about piecewise functions. Number 27 is a piecewise function. Piecewise functions have different rules for different parts of their domains. So the piecewise function we're looking at here is f of x is equal to, in brackets, 2x plus 3 over x minus 2, as long as x is not equal to 2. And obviously you can't have x equal to 2 because that would cause us to divide by 0. So it follows this rational expression rule as long as x is not 2. If x is 2, then the value of the function is just simply going to be 3. And it says find f of 2. If x is equal to 2, f of x is equal to 3 by that rule right there. If f is equal to negative 1/2, that's going to be 2 times negative 1/2 plus 3 over negative 1/2 minus 2. And since I don't like to do fractions either, two times negative 1/2 plus 3 divided by negative 1/2. Notice that I'm putting all the fractions in parentheses. Minus 2. You always put fractions in parentheses and negative sign in the parentheses with negative fractions. And I want it to give me the answer as a fraction because I have an ugly feeling it might come out to be a fraction. And it says the answer is negative 4/5. So there you go. Part C is a little more trouble because Part C says find f of A. F of A is equal to 2A plus 3 over A minus 2 if A doesn't take on the value 2. If A takes on the value 2, then f of A is 3. It's just a repeat of f of x with A replacing all of the x's. F of 2 over m works the same way. So 2 times 2 over m plus 3 over 2 over m minus 2 simplifies a little bit, but I don't know that I would bother to simplify it. I would probably leave it, since it doesn't say to completely simplify anything. And I'm going to come back to that part right there in just a second. And it's equal to 3 if 2 over m equals 2. And I'm going to come back to this part too. So those are the domain restrictions. But notice down here it says if m doesn't equal 1 and if m equals 1. Why are we worried about that? Well, if 2 over m can't be 2, let's see what m would be if that were to happen. 2 over m equals 2. That would be if 2m equals 2. And that would be if m is equal to 1. So this is equivalent to m not equal to 1. And then this is equivalent to m is equal to 1. So that's where they got that. And they actually supplied that for you. And then find the values of x such that the value of the function is 1. Well, the first part I'm going to tell you is probably pretty clear to you. If f of x is equal to 1, well, f of x isn't ever going to be equal to 1 if x is equal to 2. So we don't need to worry about that rule. What we have to do is we have to figure out what value of x would cause that part to be equal to 1. me grab a little piece of scrap paper over here so we don't confuse the other stuff. What we're trying to find here is what would cause 2x plus 3 over x minus 2 to be equal to 1. Now, if you look at it and just think common sense, anything's equal to 1 if its value here is the same as the value here. So you could just go straight to the idea that that means that 2x plus 3 is equal to x minus 2. If that doesn't seem quite all that obvious to you, then look at it this way. 2x plus 3 over x minus 2 is equal to 1 over 1, and cross multiply because 1 over 1 is the same thing as 1. 2x plus 3 times 1 is 2x plus 3. X minus 2 times 1 is x minus 2. So this is the cross multiplication way of solving a rational problem. Now what this means is if I subtract x from both sides, I have x plus 3 is equal to negative 2. And if I add 3 to both sides, add negative 3 to both sides, then I come out with x equals negative 5. That should be the correct solution. If I am the least bit afraid that I've made a mistake, then what I should do at this point is try to plug that in and make sure that actually does give me 1. So 2 times negative 5 plus 3 over negative 5 minus 2 is equal to negative 10 plus 3 over negative 7. And negative 10 plus 3 is in fact negative 7. And negative 7 over 7 is in fact equal to 1. So that does check. And there's your correct answer. Your verified correct answer. And we're ready for number 28. Number 28 and 29 are preview practice for something we're going to be doing in section 11.3. It's called the limit definition of a derivative. And you have to get pretty good at plugging in functions into this limit definition of a derivative, which is going to utilize f of x plus h minus f of x over h. So we're going to do basically the first 3 steps of the 4-step process for finding a derivative, and that's going to come up in 11.3. So you want to follow along with this problem, this kind of problem, very carefully. So in number 28, my given function is f of x is 8x plus 5. And part A wants me to find f of x plus h. So part A is step 1 of what we're going to call the 4-step process, but we're only doing the first 3 here. We're going to find f of x plus h, which means in place of the x, we're going to plug in x plus h. And then we're going to algebraically simplify this. 8 times x is 8x, and 8 times h is 8h, and plus 5 doesn't change. Then we're going to go to part B. This is the second step of the 4 steps we'll do in 11.3. We're going to find f of x plus h minus f of x. So what that means is we're going to take f of x plus h from our last step, and from it we are going to subtract f of x, which is 8x plus 5. So if I remove these parentheses, minus 8x minus 5, I'm going to add that to 8x plus 8h plus 5. And what I will see happen is that 8x minus 8x will disappear. And 5 minus 5 will disappear, because they've canceled each other out. So that means that f of x plus h minus f of x is actually only equal to 8h. And then my third step is to find f of x plus h minus f of x. Divided by h. Put it all over h. So what that means I'm going to do is I'm going to take f of x plus h, which is 8h, and I'm going to divide that by h. And that's going to be equal to simply the number 8. Now, as long as your function is a linear function, this whole process is actually fairly quick and fairly simple. F of x isn't always going to be a linear function. We're going to talk about a lot of different kinds of functions. The only difference in doing this process with a linear function and a trinomial, a quadratic function, is simply the number of steps involved and the level of algebra that we have to do. It is a little more difficult, but we can do it. So hang in there and let's go ahead and get busy with it. Think positive. Number 28. We are initially given a function, which is a quadratic function. F of x is equal to 4x squared minus 8x plus 7. And our first step is to find f of x plus h. Which means we're going to plug in x plus h for those two x's. And then we're going to multiply it out and simplify. The first thing to remember is the thing that I told you a little while ago. Please don't forget this. Please don't mess this up. Please, 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 please remember x plus h squared does not equal x squared plus h squared. And if you try to use that as your simplification, you will get in trouble and this will never work and you will be a very frustrated person. X plus h squared is x plus h times x plus h. Which is x squared plus 2xh plus h squared. Okay? So this part is going to be 4 times x squared plus 2xh plus h squared minus 8 times x plus h plus 7. And then we're going to simplify that again. 4x squared, 4 times 2 is 8xh. 4 times h squared is 4h squared minus 8x minus h plus 7. So that's f of x plus h. Part B, we're going to take f of x plus h and from it we are going to subtract f of x. So this is f of x plus h. And if we're going to subtract f of x, then we're going to have minus 4x squared plus 8x minus 7. And then what's going to happen is this and this and this are going to cancel each other out. So that f of x plus h minus f of x is equal to 8hx or xh, either one, plus 4h squared minus h. And that can be simplified because there's a greatest common factor. And that greatest common factor is h. So we'll factor out the h, which leaves us with 8x plus 4h minus 1. And you're going to see in the next step why I went ahead and did that. So part C is to take f of x plus h minus f of x, and we're going to divide it by h. So that means we're going to take this, which is f of x plus h minus f of x, and we're going to divide it by h. And what happens is the h's cancel out. So f of x plus h minus f of x over h is equal to 8x plus 4h minus 1. And there's your final answer for that. So a little bit more complicated, but not so much that you can't handle it. Number 30, it says the figure at the right shows the average price of silver for recent years, 2000 to 2012 and a little beyond. And let S of t, which is this function that we're looking at here represents the average price in dollars per ounce of silver for year T. Answer parts A through G. So remember, the year is T. The dollars per ounce is the units for S of T, which is the price of silver in year T. Is S of T a linear function? Linear function means that it is a graph of a straight line. And is it a straight line? Well, no. It is a collection of line segments. That's true, but that doesn't make it a linear function. The fact that it increases just tells us that the slope would be positive, and there are, in fact, places on this function where the slope is negative. And S of T is not a multiple of T, has no bearing on this whatsoever. That's like your throwaway answer. The correct answer is no, because linear functions have a constant slope. The slope of a linear function never changes. The slope of this function changes. It goes from being negative to positive to a little more positive, 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 more positive, stronger positive, negative, positive, positive, negative, negative. So it increases and it decreases. Therefore, it is not a linear function because it doesn't either constantly increase or constantly decrease. What is the independent variable? Remember, that's your domain variable. Your domain variable here is T. So it is the year T. Its functioning is the X. Nowhere in here was X being used as a variable, nor was it an ounce. What is the dependent variable? Dependent means that the outcome depends on what year it was. And what we're looking at here is the outcome is the price of silver. So the outcome or the dependent variable is the price of silver, which is S of T. The domain of the function, since the function we're looking at begins in the year 2000 and ends in the year 2013, because the next tick mark after 2012 would be 2013, then the domain of the function, if I could fill it in there, would be from 2000. So it would begin at 2000, comma, 2013. And it would have square brackets because it includes both those years. The range, similarly, the lowest this function ever appears to go is about $10 an ounce. And the highest it ever appears to go is about $40 an ounce. So the range of the function would be 10, 40 enclosed in square brackets because it includes the 10 and it includes the 40. What was the average price per ounce in 2008? Well, in 2008, we'll read the graph going straight up, and we see that the price of silver was $30 per ounce. And that's what you want to type in there, $30. They gave you the dollar sign. In what year was the average price $40 an ounce? Well, since we're looking at the price of the silver, we go up and see where it's 40 and read across to the function. That's the point right there, and it appears that that was in the year halfway between 2010 and 2012 would be 2011. So the year would have been here, 2011. You will see a problem similar to this, I promise you, on the first exam with somewhat similar questions, maybe slightly different, but you are going to be expected to read a graph. Problem 31 says, let C of X be the cost to produce X batches of widgets. Let R of X be the revenue in thousands of dollars. Complete parts A through D below. Graph both functions. Well, before you try to graph it on here, you probably need to figure out how to translate it into a graph on your calculator just to make life easier. The way we're going to do this is we're going to go to y equals, and we're going to type in r of x, which is negative x squared plus 8x. And we're also going to type in c of x, which is x plus 10. And since they're giving us a graph for it, we're going to cheat a little bit and take what they tell us that they want us to graph it on. And this graph actually makes sense because neither x nor y should go below 0 because we're talking about cost and revenue. You don't want negative revenue. You don't pay people to take your product. And your cost isn't going to be negative because the least it's ever going to be is what your fixed cost is, which would be $10. So we're going to start at 0 for the minimum value of both of these. Now, we don't necessarily know the right values for the maximum, but since they're giving a graph grid that only goes to a maximum x value of 20, we're going to figure that's probably going to be the part of the graph we need to see. And since their y value maximum is only 40, then we're going to figure that's as high as we need to go on the y-axis. And it looks like their x-axis is scaled by 4s. And their y-axis appears to be scaled by 4s also. So we're going to copy their window. And we're going to graph the two functions. So this is what we see. So it says identify the vertex of r of x. Okay, the vertex of r of x is the very, very top point on r of x. It's also referred to as a maximum. There's a couple of ways we could find it algebraically, but the easiest way, since we had to graph it anyway, is to actually find it on the calculator. So what you do is, on your calculator, you go to the second and trace button, and you choose maximum because it is a maximum value. And you press enter. And then you want to get to an x value that is to the left of the maximum. So right now we're not even seeing it, but now it's starting to show up, so we keep clicking. We haven't reached the maximum yet. But I think you can see here that we are, in fact, to the left of that x value, so we hit enter. And then we trace to the right bound, or to the right side of that maximum value. So it looks like we're right about close to it there. We'll keep going a little further. And we're now past that value. So it's going to look between whatever this x value was and whatever this x value was. And we're going to let it guess because it guesses a lot better than we do. And it says the maximum value is at 416. So the vertex of r of x is at the point 4, 16 in parentheses. It says to identify the y-intercept of the cost function. The y-intercept is where x is equal to 0, but we have to be on the cost function. So we're going to say let x be 0. But the first one that it shows us is 0, 0. And if you can just barely see it blinking here, it's actually showing us the origin. But that's because we're not looking at the cost, we're looking at the revenue. If we want to look at the cost, we need to move to y2, which is the cost function. And it says x y-intercept is 0, 10. That should make sense because if x is 0, then y is going to be 10. So this should be the point, parentheses 0, 10, close parentheses. And you would graph those two functions here on MyMathLab. Part B says find the minimum break-even quantity. Now you notice here there's two break-even quantities. There's one here where cost equals revenue, and there's another one here where cost also equals revenue. You're going to break even the first time at the minimum value at the value of that point. It's easy to find break-even values. You hit second, trace, and tell it you want to find the intersection. The only thing that you want to do is you want to first trace close to the intersection point that you want. So try to get your cursor close to the one you want. And then hit enter 3 times. So the minimum break even is at 212. The minimum break even quantity is 2 units of whatever it is for probably $12. Let's see. Yes, it's 2 batches for $12,000. So this equation that you're going to enter here is basically where negative x squared plus 8x is equal to x plus 10. And even though you can type that equation in there, you can solve it on the calculator. And then the minimum break-even quantity is 2 batches sold for $12. Part C says find the maximum revenue. Well, the maximum revenue came from that maximum point. So the maximum revenue was $16,000 for selling 4 batches. The way that you actually find it is you find, and since it says revenue, revenue is R of X, is you find the Y coordinate of the vertex of R of X. And the maximum revenue is 16, and then this is $1,000. Then it says to find the maximum profit. Maximum profit's tricky because you can't get that straight off this graph. If you want the maximum profit, you need to keep in mind that profit is equal to your revenue minus your cost. So your profit equation, which we usually call P of X, is equal to revenue, which is negative x squared plus 8x, minus cost, which is x plus 10. And that's negative x squared plus 8x minus x plus 10, which is negative x squared plus 7x plus 10. And you could probably try to factor that to figure out where you have 0 profit, but that's not what we want to know. We want to know where is it maximized. So what we want is the vertex of P of X. So what we're going to do to get the vertex of P of X is, once again, we're going to graph it, although there is an algebraic way to find it. It requires memorizing formulas, and I'm not all about memorizing formulas. I'm going to go back here. I'm going to clear out my revenue and my cost equation. I'm going to enter in my profit equation, negative x squared plus 7x plus 10. And I'm going to graph that. And as I expected it to, just like R of X, it is an upside down parabola, so it has a maximum value. And I can find its maximum by going to second trace and choosing number 4 maximum. And make sure that I go to the left of the maximum press enter, and then go to the right of the maximum and press enter and tell it to find the vertex, and it tells me the vertex is at 3.5 if you round it off to a reasonable number of decimals, and 22.25. So that means X is 3.5 batches. And P of X is $22.25 thousand in profit. So P of X equals this expression right here. And the maximum profit is $22.25 thousand. And if you write 22.25 thousand, keep in mind you're moving that 3 decimal places, so that's 22.250 to get the decimal out here to the third place. And that's $22,250 when you enter that answer in. If it doesn't give you $1,000 as the option for the word. If you didn't have Math 1630 last semester, chances are this question is probably a little fuzzy in your mind because you don't remember having done one like this. But we did, and we have in the last few years been doing modeling in Math 1630. So suppose the following table gives the median age at first marriage for women in a certain country for some selected years, complete parts A through E. And it says to plot the data using T equals 40 for 1940 and so on. So what we're going to do is we're going to use the calculator to do this. We're not going to draw the graph by hand. So we're going to turn the calculator on. I'm going to go to the Y equals and clear everything out there. And on the home menu, I'm already cleared out. So what I'm going to do this is I'm going to first hit the Stat button. And I'm going to hit Enter. And it's going to give me some lists of data. This is just like a spreadsheet in Excel, and we could, in fact, do this problem in Excel. My first column of values is going to be my year. So we're going to delete all these numbers that are in there out because we don't want those numbers. And I'm also going to delete out the ones that are in list 2 because in list 2 I'm going to put those ages of the women at first marriage. So my first X value, my first year value is going to be 40 for 1940, 50 for 1950, 60 for 1960, 70 for 1970, 80 for 1980, 90 for 1990, and I can't put in 00. I'm actually going to be putting in 100 because 40 for 1940 means it was 40 years after 1900. So in 2000, it was 100 years since 1900. And then 2010 is going to be 110. And then my Y values are going to be those ages. So in 1940, the median age was 22.9. In 1950, it was 21.17. In 1960, it was 20.8. In 1970, it was 21.4. In 1980, it was 22. 1990, it was 23. 1991 it was 25. And in 2010 it was back up to 27.8. Now, if you're at all curious about why these would be behaving the way they do, what you want to consider is that in 1940 and right before 1940, that was the era of the Depression and coming out of World War II. And people that didn't get married before they went to World War II, those women couldn't marry until after World War II when their fiancés came home. In 1950, something similar was happening still because we had the Korean conflict in the 1950s, so that age was coming down, but there were still a lot of guys off in the military and they were getting married when they were older. By 1960, they were pretty much marrying at a younger age. In 1970, that age started to increase because women started getting more education, and they were had begun to delay their marriage until after they got educated, and that trend progressed through the 80s and the 90s and up through 2000, and now women are waiting until they've pretty much gotten established in their careers to get married, and that's why that median age now is about 28. So here they're just wanting you to put in these values that I put into list 1. They want you to enter in those values. And then it wants us to show a graph. Okay, the way that you get this graph is you go to the stat plots, which is second y equals. You choose one of those plots, making sure all of the others read off. You choose one and turn it on. And the scatter plot is the very first plot, so you don't have to worry about any of those others. Those are all statistical graphs. And you tell it where you put those lists. Your age list is in list 1, and your marriage age list, or the year list is list 1, and your marriage age list is in list 2. And you can use any of those marks, but I generally use the little box because it's easier to see the marks. And there's 2 different ways you can go about this. They didn't give us a scale. If they had given us a scale for X and Y here, we could have copied theirs, but they didn't give us one. So what we're going to do is we're going to let the calculator choose the window. We're going to go zoom and then scroll down to number 9, zoom stat. Because we use the stat button to enter the data, we're going to have it zoomed to fit the data we put on the stat button. And this is the graph that we see. Now clearly, this graph is a sort of a quadratic looking graph. It seems to be curved, and it's opening upward. So that tells you D is not the correct graph. C is not the correct graph. And although B opens up, it reaches a minimum at a far higher place than what ours does. Our minimum is back along here, not all the way up to here. So we best match graph A. And the question, would a linear or quadratic function best model the data? Well, a linear function wouldn't model this data because it wouldn't follow the trend of the data. The data is definitely exhibiting a curve. So that means that we would want to use a quadratic model. And the key property is that the points on the graph constantly increase or have the same slope. Then a linear model is better. Otherwise, a quadratic model would be better. And based on the graph of the data, the points are opening upward, so the quadratic model would best fit the data. Let's see, what do they want us to actually choose the words for it? Okay, they're generally moving down from left to right, or they look like they're close to a straight line, then that's a linear model. Our points look like they're close to a simple curve, so that's why it's a quadratic model. Using the regression feature of a graphing calculator, find the quadratic formula that best fits the graph. Well, that's exactly what we're doing. The way that we do that is we hit the stat button again. We've already entered the data, so we're going to go over to the Calc menu. And we're going to enter a quadratic regression formula, which is number 5, quad reg. Do not confuse QUART reg with QUAD reg. It is not a quadratic equation. It is a quadratic equation. Quartic regression is actually a 4th power equation. So we're going to choose quadratic regression. The 3 things we're going to tell it are where the lists are and where to put the equation. So our lists are, first, the years are in list 1. That has to come first because that's the dependent variable. The ages, on the other hand, are in list 2. And you put a comma between those. And then we want it to store our equation by going to the vars key and choosing yvars and functions. We're going to have it store our equation in y1 so that we don't have to retype it. And we're going to hit enter. Now it does give you the information to write the equation here, but we can also simply go to the y equals menu and see the equation there with everything already typed in. And it says use integers or decimals for numbers and round decimals to 4 decimal places. So we're actually going to do that on our graphing calculator. 4 decimal places means we're going to move the cursor to the 1, 2, 3, 4th decimal place. Look at the next number, and since that's a 6, the 4th decimal place will round to a 2, and then we're going to delete the rest of those decimals. Be careful and don't delete your X. Then we're going to go 1, 2, 3 to the 4th decimal place here, and the next number is a 5, so that's going to round up. And since 9 rounds up to 10, that means that 5 is also going to round up to 6. And then we're going to delete the rest of those. And then 34, here's 1, 2, 3, 4th decimal. The next decimal is a 2, so we're just going to delete the rest of the decimals and leave the 4 there untouched. So there's your equation. And then choose the graph. Well, now if you paid attention, this should be a give me question. We chose graph A, which looks like this. The match for graph A down here is graph B. And if you graph it on your calculator, that is what you'll see. This one, I really wish it wouldn't do it the way that it did, because really I would just assume you know what that equation is as we gave it on y equals. So for anybody that typed in something here and got it wrong, I'm going to give you, I'm just going to give you credit for it if you missed this one, because I'm not interested that you know how to do this part. I just couldn't delete this part without changing the whole question. So everybody's going to get credit for part D. And then part E, it says graph the function on the same window as the function from part C. And we've already seen that it looks like, let's see, which one is it? This one, it's graph D. And there is no work to show. You don't have to show me any work on that. So going now to question 33. The table below gives the coal consumption of the country for selected years. Use the table to answer parts A through F. We're going to go back and change these years. We would use 50 for 1950, so I'm just going to delete 1940, and I have 50, 60, 70, 80, 90. That's 2000, that's 2010, and 2012 would be 112 years. And then my millions of short tons I'm going to type in. And make sure your lists are the same length or this won't work. And it says to draw a scatter plot. Okay, the scatter plot, since we already have stat plot set up as a scatter plot with the years in list 1 and the short tons in list 2 and the mark is the little square, we are going to have to set up the window. So we're going to go to Zoom Stat, because the same window we used last time isn't going to work now. And this is what we see. And it tells us to use a quadratic regression feature to get a quadratic equation. Okay, we're going to go back to Stat, Calc, Quadratic Regression, List 1, comma, List 2, comma, vars, y vars, function, y1. And we're going to look at the equation. And it says round to 3 decimal places is needed. 1, 2, 3. The next one's a 2, so we're going to delete it. 1, 2, 3. The next one's 0, so we're going to delete it. 1, 2, 3, and the 4 is 0, so we're going to delete that. And if you went to your quadratic regression here, whoops, yes, that's going to be changed. I forgot to hit that first. So let me go back here. 1, 2, 3, delete the rest of it. 1, 2, 3, that's going to become an 8 and delete the rest of it. 1, 2, 3, that's going to become a 7 and delete the rest of that. So there is your quadratic equation. And if you graph your quadratic equation, you see that it really doesn't fit very well at all. And that shouldn't be surprising, because it's trying to hit as many of the points as it can. The problem is the pattern presented here is not characteristic of a quadratic equation. So what we're going to do then is we're going to quit from here. We're going to go back to Stat. We're going to go over to Calc, and we're going to choose a cubic equation. So again, list 1 for the x's, list 2 for the y's, vars, y vars, function, and I'm going to keep the other equation, but I'm going to put this new one in list 2. I'm going to go ahead and let it calculate the equation, and then I'm going to go to the y equals menu, and I'm going to turn the quadratic equation off. You put your cursor on your equals and hit enter, and it turns the equation off. And then I'm going to start rounding my cubic, so it wants me to round it to 3 decimal places. So there's 1, 2, 3, and that means that's going to become a 7. And delete till I get to the x. 1, 2, 3, and that's going to become a 5. And then I'll delete the rest of it until I get to the x. 1, 2, 3, and the next one's a 0, so I'm going to leave that unchanged and delete until I get to the x. 1, 2, 3, and the next one's a 5, so I'm going to change that to an 8 and delete the rest of the decimals. So now I'm going to hit graph, and the only equation I'm going to see is the cubic equation, so that I can get a clearer picture of whether it fits. And I see that the cubic equation actually fits pretty well until toward the end. So you would choose the graph that looks like this. And it says, which would be a better fit? Well, I think it's pretty obvious that the cubic appears to be a better fit. And it's not because coal consumption is typically modeled by a cubic function, because that's not true at all. We have no idea what kind of function models coal consumption. But we know that this particular function fits because it passes closer to the data points on the scatter plot. Okay? And they do not both fit equally well. And to verify that with you, I'm going to turn the quadratic back on and remind you of what it looks like. There goes the quadratic. The quadratic really doesn't fit at all. So the answer is D. The cubic fits better because it passes closer to the data points. And we're almost finished. And although I can use the calculator to demonstrate to you how to do both of these problems, I think I'm actually, to begin with, going to show you the algebraic way to do it, and then we'll try to verify it maybe graphically. The one thing I want you to remember is that exponential expressions can be solved by an algebraic process called logarithms. But we don't necessarily have to solve number 34 by logarithms. This says solve for x. What I'm wanting you to understand here is that when I'm asking you 11 raised to the x is equal to 121, I'm actually only asking you what power of 11 gives 121 is the answer. And that's easily answered by nothing more than trial and error. 11 to the first power is simply 11, but 11 to the second power is 11 times 11, which is in fact equal to 121. So the answer here is that x equals 2. 11 to the second power gives you 121. You can do that on a graphing calculator, and I am going to show you how to do this one on the graphing calculator also, but I'm going to show you the algebraic process on the other one. I'm going to clear off some things. And this turns off the graphing plot. Not that it matters, because we're not going to be using the graph right away. I'm going to clear off the home screen. I'm going to go back to y equals, make sure that plot was turned off. And in the first equation, I'm going to enter 11 raised to the x power. And then in y2, I'm going to put in the number 121. Now, there's no reason to go to negative powers, because negative powers would be like 11 to the negative 1, which is 1 over 11, and 11 to the negative 2, which is 1 over 11 squared, and so forth. So my powers are going to start at 0. And I don't really have to let them go up very high. Even if you let them go up to 10, you're going to come up with the right answer. I'm going to let mine only go up to about 5 and scale it by ones. My y minimum value is going to be 0. If I put in 11 to the 0 power, I'm going to get 1. That's the lowest I'm going to ever get. So y equals 0 will accommodate it. I need to go up as high as 121, because I'm going to need to see where 121 crosses 11 raised to the x power. So I'm just going to put in 150. And it doesn't matter what I scale by. I'll let it scale by tens. And I'm just going to hit graph. And what I see is 11 raised to the x power gets to be really, really large really, really quickly. And in fact, by the time x is only 2, I see that it's reached the value of 121. I can verify that a couple of ways. One way is to hit calculate, choose value. Since I already had an idea that it would be 11 squared, it shows me that 11 squared is 121. The second way I could use is I could go second and trace and tell it to find me the intersection point, which is also really quick. I just simply hit enter 3 times and it tells me 11 squared is equal to 121. Now, solving the equation e to the x minus 2 equals 17 can work similarly. You simply go back to y equals and you put in the number e. E is actually a number. It's on second and ln. And you enter the power as x minus 2. And then y2 is going to be 17. And again, on the window, I'm going to try and go just from 0 to 5 because, hopefully I'll see where they intersect. But my window doesn't need to go up to 115. I'm only trying to go to 17. So I'm going to try to go up to, let's say, 20. And then I'm going to hit graph. So here goes e to the x minus 2, and there goes x equals 17. And again, I can sort of guess that it might be 5, but I know it's not quite 5. So trying to guess a value is not helping me much. I'm going to use the intersection. I'm going to go down to number 5, intersect. And it says the value of x is 4.833213. And it says round to 4 decimal places, so that would be 4.8332 would be the answer there. Now, if you want to talk about the algebraic solution of that one, and we could have employed something similar on number 34. We just didn't. But the algebraic solution for e to the x minus 2 is equal to 17 is based on the fact that the natural logarithm is the base e logarithm, and the natural logarithm of e is 1. Now, unfortunately, he always comes up with a power, so you have to tell it e to the first. And he'll come back and tell you that's 1. This is the exponential form. This is the logarithmic form. This is the equivalent of saying e to what power equals 1. And the power is the natural log. What this lets us do is if we take the natural log of e to the x minus 2 power, that's actually equal to x minus 2 for the power. But if we take the natural logarithm of e to the x minus 2, we also then do the same thing to both sides of the equation. We take the natural logarithm of 17. Now we can solve this equation because the natural logarithm of 17 is simply a number. It's 2.833211, yada, yada, yada. And if I add 2 to both sides of this equation, I have x. So the natural logarithm of 17 plus 2 is 4.83. 8, 3, 3, 2. And you're finished. So one way to solve exponential equations is if the base of the exponential equation is e, use a natural logarithm on both sides because that's the base e logarithm. If it is not e, if it were 11, then you would take the base 10 logarithm. Going back to the other problem, I would take the base 10 logarithm of 11 to the x power is equal to the base 10 logarithm of 121. Or you could even still take the natural logarithm of 11 to the x power is equal to the natural logarithm of 121, and you could solve it that way. But I gave you deliberately one just to get you in the idea that what you're asking yourself here is how many times do you multiply 11 times each other to get 121? And I believe that is our last problem. So we are finished. And thank you for being patient because I know this is a very long recording. And I hope this has helped you. And I will have it posted into